Welcome and hello. This is a video exercise in HEC ResSim, and in this exercise, I'm going to be talking about tandem release rules. What I'm going to do is create a reservoir network with two reservoirs in series on the same river, and I'm going to use tandem operation rules and show you guys how that works. All right, what I have on the screen here is a brand new fresh instance of HEC ResSim. I'm going to go ahead and start from the beginning, which means creating a watershed. And then we'll build the network out and then run the simulations. So here we go. We'll go to File, New Watershed, give that watershed a name, and then select the location of the directory that we want that watershed directory to be saved to, units, time zone, and we're off and running here. Okay. All right, so the watershed directory has been created. Let me just resize the window here. And we're going to start by creating a stream alignment. So let me hold down Control and then click a few times and then let go of Control before your final click and give the stream a name. I'll just be generic with my naming here. Then I'm going to click on the computation point tool and then hold down Control, single left click on that stream alignment, and then we'll give that computation point a name. And then I'm going to go ahead and create a reservoir here. Hold down Control on the upstream end and then let go of Control. I'll call this Reservoir North. So pretend we're looking at a map where north is up. So I'm going to have a second reservoir in just a moment. Put a computation point there between the reservoirs and then select the reservoir tool again. Let me go ahead and make a reservoir south. All right, great. And just for good measure, let me put one computation point at the downstream end of our network. I'll call it CP, what are we up to? 7. Okay, one more thing before we are done with the watershed setup module is I'll go watershed, configuration editor, and then configuration new. Config 1 is fine. And then okay. Both of our reservoirs are in the config 1 configuration. So I'll click apply. Okay, great. Let me go ahead and save this watershed, and then we can move over to the next module, which is the reservoir network module. I'll start by clicking network new, and I'm just going to call it network 1. We're only going to have one network in this exercise, so it doesn't really matter what we call it. Then I'm going to connect the network by clicking the reach tool and then drawing in my reaches. So I click the reach tool over here. I hold down Control on the upstream junction, give it a click, let go of Control, and then click again on the next adjacent downstream junction. I'm going to do that for each of my reaches here. And I'm just going to accept the default name it gives me, like CP6 to CP7. That's fine. All right, let me go ahead and save the network, and we're good. I'm going to go ahead next and assign an inflow to the CP1. So I got the junction tool selected, or you can also use just the generic mouse pointer tool. Right click on the junction, edit junction properties, and then select local flow as my tab. And I'm just going to call it inflow at CP1 with a factor of 1. The flow rates we can just assign right now. I'm going to create a time series data set. So I'm going to click OK and then head over to Tools, HEC DSS View. And what I'm going to do now is, I got to create a file, new. I'll just call this time series data. And then that creates my .dss file. What I'm going to do is for this exercise is just have a constant inflow at this upstream junction CP1, and it's going to be a flow of 10,000 CFS. So we'll work with that and see what happens. So to do that, I'm going to go data entry, manual entry, and then let me fill out the path name parts here. I'll just call it river, location, and then this will be inflow, and I'm going to call this 10,000. So it's a constant value. For the time duration, I'm going to do this for the month of May 2024. So we will start on May 1. And the time, this will be an hourly time step. So I'll say the first hour of the month. The units will be in CFS. So we are ready to input our data. One quick way to do this is to select the automatic generation tab right here. and then we'll type in our value that we want to use, which is 10,000. And then the end date time will be the end of the month. So that'll be 31 May 2024. That'll be the last hour of the month. And then click generate. So it gave me all my values here, 744 hours in the month. Yep, for a 31-day month. We're good. I'll click save, and then no, we don't actually have to make any more edits. We can take a peek at this time series, and we see a constant 10K for the month of May 2024. So we're good there. That's ready to go. We're going to go ahead and assign that time series data set we just created a little bit later in the video when we set up an alternative. Before that, let's go ahead and define the reservoirs. We have our north reservoir and our south reservoir. So defining the reservoir involves a few things. We're going to have to define the reservoir geometry. So we do that in the pool section. We do that by just pasting in or typing in our geometry for that reservoir. So it starts at 1350. It goes up to 1500 as far as the elevation, and the total storage for this reservoir is 50,000 acre feet. I'm going to start by making both the north and south reservoirs the exact same, like the exact same geometry, the exact same zones, and look back data. So this is north. Let me go ahead and just head over to south real quick. Oops, yes, I want to save changes. Click on the pool and then paste in the same geometry. Then I'll click apply. Okay, let me go back over to the north reservoir, and now we have the dam. So I'm going to type in some data for the dam. We know the dam top is going to be 1500. And then let me add a controlled outlet. I'm going to paste in some numbers for the controlled outlet. This is plenty of outlet capacity, so that won't be a constraint in our simulation, and I'll just pump it up more with a few gates. Okay, cool. And then let me head back over to the south reservoir and then make the same changes here. I'll say 1,000 and then add a controlled outlet and then paste. Say there's 3 gates and then apply. Okay, now we're ready to head back into the north reservoir. Let's go ahead and create an operations set by clicking the operations tab and then operations new, operations set 1. All right. And the default zones it gives me is flood control, conservation, and inactive. And that works for me. So for flood control, I'll go ahead and type in 1500. For conservation, this is the guide curve now. The top of the conservation zone will be, let's go 1460. And then apply. And then the top of the inactive zone will just be the bottom of the reservoir, which will be 1350. All right. Let's do the same thing with the south reservoir. Now, I'm not going to be adding any rules right now. I'm just going to do my first simulation without rules, and then we'll get into those tandem rules that promised. Operation set 1, okay. And then here are the 3 zones. So I'll just type in the same numbers. Conservation and inactive. Okay, so over here in the plot, we see the 3 zones. There's inactive zone, here's the conservation zone, and then the flood control zone. All right, looks good. Let's head back over to our main page and set the alternative up. Here is the alternative editor. I'm going to go ahead and click alternative new. I'll just name it alt 1. And then let's see, for the run control, I'll use a 1 hour time step and accept all the other default settings. That's fine. For the operation set, I'll just assign it to operation set 1 for both reservoirs. That's the only one we have to choose. Okay, now for the look back data, it's asking what is the starting elevation of the 2 reservoirs. So I'm going to just say it's equal to the guide curve elevation of 1460. And then the initial release is going to be, it's going to be 11,000 CFS. And the reason I'm setting it to 11,000 CFS is because I want to create some sort of downstream demand of 11,000. You know what, let's make it 12,000. 12,000 CFS. All right, so our inflow is 10,000 CFS, and I'm going to create a downstream demand. In fact, let me do that now. I'm going to create a rule for the downstream, the south reservoir, and it's going to apply, it's going to be a function release rule. So it's just a constant release all year long. And I'll do that by going right click, add rule, and I'll just call it 12K. This is a minimum. All right. So function, let's assign it to the controlled outlet. Release function is correct. This is a minimum. And then I will base it on the date because this is year round. And I'll just say 12,000. Apply. Okay. All right, so we have our reservoirs, the zones, the rules, the alternative setup with the correct look back data. I think we're good on our reservoir network. So I'm going to go ahead and network save. Okay, I think we're good here. And then head over to the simulation tab. All right, let's go ahead and create a simulation, and then that will bring in our network. So I'll just call it sim1. And then the look back period will begin at the beginning of the month. So remember, this is May 2024. I'm going to go May 2024. First hour of the month is fine. The beginning of the simulation will start, we'll just start it a few hours later. So we'll say May 21st, and then we'll say it's at 5 a.m. So we'll give it a few hours to warm up. And then in the end of the month, the end of the simulation will be about May 22nd. And then that can be the final hour of that day. All right, so I'm going to select alternative one and then click OK. And then that is our reservoir network. Let's go ahead and click compute. Hold on a second. Okay, I forgot to actually load up the time series data. My bad. Let me go back to the reservoir network, click alternative, and then, yeah, the time series tab, I totally forgot. So I'm going to go ahead and select that time series path we created, that constant 10,000 CFS, and then open up the file. Here it is. And then I will select it and then hit set path name and then OK. So that's in place there. That's important. Save, and let's save our network and then go back to the simulation module and try running it. And this should work. Nope. Voiceover, Timmy here with an explanation. What happened was I first created my alternative without a time series data. Then I created a simulation and assigned that alternative to the simulation, ran the simulation, and had an error. To fix that error, I now need to fix the time series data in the alternative from the simulation module, not from the reservoir network module. So that's what I'm doing here. Let's assign the record, click set path name. Okay, so that's assigned. And let's save that alternative and then compute. Okay, so we have some results here. Woo! Um, let's take a look at the plot for our north reservoir. And as you can see, we have a 10,000 CFS inflow and we have a 10,000 CFS outflow. So basically the north reservoir has 10,000 CFS coming in, 10,000 CFS leaving, so that it maintains its guide curve elevation there at 1460 feet. The south reservoir is probably a little different looking. Okay, so we have a 10,000 CFS inflow from the north reservoir, but because we have a 12,000 CFS demand or a minimum release rule, we have that's what's happening here with the green line. It's releasing 12,000 CFS until the elevation of the water in the reservoir pool of that south reservoir can no longer release 12,000 CFS. So that's flow rate basically goes down to 10,000 CFS, which is the inflow, which is all it can do. So what we're going to do here in the first alternative is I'm going to make a copy of the first alternative, actually, what we just did here. I'm going to make a trial, and that trial is going to have a tandem release rule. So let's go ahead and make those changes. I'm going to go ahead and just do a right click and new trial. And so I'm going to just call this size 1-1. Yeah, 12K demand tandem. Now they will all be tandem from here on out, but okay, so I have my trial name here. I'm going to right click and then edit the run. I'm going to start by clicking on reservoirs and let's go to the north reservoir. So when you're creating a tandem rule, you only have to assign that rule to the upstream reservoir. And then the operations tab, I'm going to go ahead and right click and create it new. And then I'll just call this tandem. This has to apply to the reservoir itself. You can't create a tandem rule for like a controlled outlet or anything. And then tandem is right here. Okay. All we have to do in this part is to select the reservoir, and that's already set because it's the only other downstream reservoir, the reservoir south. So I'm going to click apply, and then I will apply that rule to all zones. Apply. And let me just take a quick peek at the south reservoir. Okay. I should probably apply this to all zones, but conservation zone is the only one it really applies to. Okay, let's go ahead and run that trial one with the tandem rules and see what happens. One thing I do want to touch real quick on is the look back data. So now I believe I want to set the release to 11,000. And oh, this should probably be 1460. I'm sorry. And this will be 12,000 still. Yes. Okay, let's see what happens there. Okay. And okay. And let's run. Okay. Looks good. I'm going to look at just the results from that trial here. Let's look at the North Reservoir results first. Let me make it full screen. So there seems to be something weird going on the first hour before the look back, and I'm just going to kind of ignore that. But let's go ahead and zoom in on the results that we want to see. Okay, so I'm zoomed in on the results. This is the North Reservoir, so we're seeing the same 10,000 CFS inflow, but we're also seeing a little bit different number. The release is not 10,000 anymore, it's now 11,000. So it's releasing 1,000 CFS above what it's getting. It has a working deficit here of 1,000 CFS, and we see the results of that up here in the elevation because the elevation drops. All right, over in the South Reservoir. Okay, I zoomed in on the results for the South Reservoir, and our inflow here is that 11,000 CFS, and the outflow is the required 12,000 CFS. It looks like it made it to day 7 before it finally wasn't able to provide 12,000 CFS anymore. So this is how the tandem release rules work. Both the reservoirs are working together to achieve what's called a storage system balance. And they do so by being linked by that tandem rule, and the upstream reservoir is controlling how much it releases by knowing the downstream reservoir and its storage and its downstream minimum flow requirements in this case. So at the beginning of the simulation, both reservoirs are at their guide curve elevation of 1460. And as the days start passing by, the guide curve elevation is no longer achieved, but in terms of storage, both the reservoirs have the same percentage of what would constitute the storage of the guide curve elevation. So what I mean by that is at the beginning of the simulation, both have 100% storage of their guide curve elevation. But say after a couple days, they may both only have 90% of their storage. And we see that in this example quite clearly because 10,000 is the inflow, 11,000 is released from the north reservoir, and then 12,000 is released from the south reservoir. So we know that both reservoirs are equally losing 1,000 CFS of their storage as the days pass by here until day 7 they can no longer keep that up. So what I want to do next is create a trial, and what I want to do is double the storage capacity of the north reservoir. I'll keep the time series the same, so we'll still have a constant 10,000 CFS, and I'm going to keep everything else the same as well. The tandem rule, the downstream release rule from the south reservoir, and we're going to see what happens. And what I predict will happen will be that the north reservoir, since it has twice the storage, it will be releasing more than 11,000 CFS. It's probably going to be releasing, well, say 2/3 of 2,000 would be 1,333. So I expect it to be not 11,000, but 11,333. And then the south reservoir will be contributing, 667. All right, let me go ahead and just make a copy. Instead of copying the alternative, it's actually a little quicker and easier if I just create a new trial based on that trial one. So I'll do that. I'm going to say size is going to be 2-1, meaning that the north reservoir is twice the size of the south, comma, 12K is my downstream demand, and then tandem again. And okay. Okay. All right. Right click, edit, run. And I'm going to click on reservoirs. And then I'm going to select the north reservoir and then the pool. All right. So the north reservoir used to have a total capacity of 50,000 acre feet. So I'm going to go ahead and paste in double the numbers. And now we have 100,000 acre feet. And that's the only change I want to make for this second trial. So let's go ahead and click apply and okay. And then okay here. And then compute. So that computed. I'm going to go ahead and look at the results. Let's start with that north reservoir. Okay, I've zoomed in to the north reservoir results. And again, we have a constant CFS, 10,000 CFS for our inflow. And then the outflow is, as I predicted, 11,333. Now it can last until about 10 days into the simulation. Now we're looking at the downstream south reservoir. This is our inflow here, which is the same as the release from the north reservoir. And then there is our 12,000 CFS. And again, we're able to um, release that for about 9.5 days. So halfway into day 10 is when we can no longer have enough storage to make that release based on our constant 10,000 CFS to the north reservoir. Okay, let's do one more trial just to kind of reinforce this whole idea. And this final trial will be to increase the north reservoir again so that it's 150,000 acre feet. So it'll be 3 times as large as the original south reservoir size. I'm going to head over and go new trial, and then I'll just name it size 3-1. 12K is our downstream demand, and then tandem. Okay. And then I'm going to go right click, edit, run, reservoir. Again, I'll select the north reservoir. I'll select the pool. All right. So instead of 100,000 acre feet of storage, we paste. Now we have 150,000 acre feet of storage in that north reservoir. So we are ready to run the simulation one more time. All right. Looks good. And let's take a peek at that upstream reservoir plot results. Go ahead and think to yourself what's going to happen. We have an inflow of 10,000. We have a downstream requirement of 12,000 between the two reservoirs, and the north reservoir is 3 times the capacity. So as far as storage goes, the ratio would be 1 to 3. So I'm guessing that the outflow here will be at the north reservoir would be 3/4 or 75% of that 2,000 CFS additional requirement. 1150, right? 11,500. Okay, so I've got the north reservoir on the screen here, constant 10,000 inflow, and then 11,500 is the outflow. All right, let's head over to the south reservoir and look at the plot there. What I've been doing is clicking plot, and then as you may notice, there's a little bit of weird data going on in the look back period, so I'm just going to zoom in and kind of ignore that. I could change the axes data, but okay. So here we go. We have the inflow. That's to the south reservoir, which is the release from the north reservoir, and that is our 11,500 CFS, and the 12,000 CFS release is right here, and that lasts for about 12.5 days. So as we increase the storage, of course, we're able to satisfy that same 12,000 CFS downstream demand, that minimum flow requirement based on the release function rule for a longer and longer period. Now we're up to 13 days. So anyway, this was an example of tandem release rules and sort of describing the whole idea of implicit system storage method, which is how ResSim balances reservoirs that are in the same reservoir network. And one way to create that reservoir network is via these tandem operation release rules. If you wanted to define a balanced reservoir system storage differently than this implicit as sort of a constant percentage of storage, then the user can do that. And that's sort of beyond the scope of this video, but I just wanted to say that that is possible too. You don't have to expect your reservoirs to fill up or to drain based on an equal percentage based on their storage. but that would be a user-defined, explicitly defined system storage balance method. But anyway, enough for this exercise. I hope what you found here was helpful in getting you started and understanding sort of the basic of how tandem release rules work in HEC ResSim.